In this screencast, I'm going to briefly describe how to use an interactive simulation that solves mass and energy balances for a reactor with heat exchange. So this simulation is not concerned with kinetics or equilibrium. Assumes the reaction can go to completion, and changing flow rates just changes the mass balances, the energy balances, because what we're doing is we're fixing either the extent of reaction or the outlet temperature by clicking on one of these two buttons. And if we have the extent of reaction selected, then this slider allows us to pick the value of the extent of reaction, but we're limited. So for example, the extent of reaction is how many moles per hour of component A reacts. If the reaction is A plus B goes to C, we can't have the extent of reaction larger than 75 moles per hour because that's the feed rate of B. And so that's why it says sliders may adjust their ranges to prevent impossible scenarios. We'll see in some conditions we change one slider, the other slider also changes because of exactly this reason we're limited in what conditions we can reach. Likewise, the sliders are set, the heat removal rate is set, we can't go below 25 degrees for the outlet. So let's look at the interactive simulation and see the behavior of the system. So here's the interactive simulation, and I've set the flow rate of B coming in at 39, so then as I increase the extent of reaction, of course the outlet temperature goes up because we're looking at an exothermic reaction, and we fix the heat removal rate at a relatively small value, but what you'll notice is the limit of this slider is 39. If I were to decrease the hydrogen flow rate, now the limit goes down. Now it's only 33 because that's the flow rate of B. So I'm going to increase the flow rate of B. I can increase the flow rate of, this is a capital I for inert, so I increase the flow rate of inert. And this is going to affect the temperature because we have to heat up that inert. It's not involved in the reaction. It doesn't change the kinetics for this particular simulation because we're only looking at the mass energy balances, and we assume kinetics stay the same. Well, I can also increase the heat removal rate, and of course that drops the temperature, and I can drop the temperature all the way down to 25 degrees if I remove a very large amount of heat. So the other option is we can set the outlet temperature. Now the slider is outlet temperature, and then we can adjust the heat removal rate, and what that's going to do is change the conversion because we fixed the outlet temperature. So the idea of the simulation is strictly to help us carry out mass and energy balances for this system.